Okay, let's try pass 3 together here. Pass 3 hits. Starting like this, which is the final product of the previous pass, 450. It's a miss. But it's now in here. It brings in 451 as well. 2 and 3 is not in here. 450 again. That's a hit. 451. Hit. 449. Hit. 0. Oh boy. I would like to evict some of this least recently used stuff, but we can't do that in direct mapped cache. We're starting to see the downside of it. 0. It's now in there. Brings in 1. 0, 0, 1. Hit, hit, hit. 0, 0, 1. 2, 3. Goodbye. Look at the stale data sitting at the bottom of this cache, unevicted. 2 was a miss, brought in 3, and 3 was a hit. Right here. 0's a hit. 2, 2, 0, 1. 2, 2, 0, 1. 449. We have this thrashing behavior. 448. 449. 0, 1 is ejected. 449 the second time is a hit, and so is 448. 451. 2, 3's gone. I really wish we had a set associative cache which gives us choices of who to evict. 2. So we ended up with this many hits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 again. Which is excuse me, sort of a fluke. So overall we have 10, 20, 30, 40. Hit rate 40 out of 60 for the 3 passes. And the other part of the question, show the contents in a table of the cache at the end of each pass. That's what the cache looks like at the end. I'll take a screenshot of that and upload it with the video, I hope. I'm going to change the question and bring back another video. Okay, we're going to try a few variations on this question. The first variation is this. I changed it to 8 words per line. Nothing else changed. Just 8 words. So, if we look over here, I had to erase these tables, and let's figure out the cells involved in our little program are going to be 0 to 7. That's block 0. And then it's going to be 8 to 15. Those are all together in block 1. And then if I just scroll down a bit, and I need to start at maybe 448, which is not, no, I'm going to have to start at 440. 448. Let's see, we have to get something that is divisible by 8. And so 448 divided by 8 is 56. 448 to 453. That's block 56. Just divided by 8. And then we need to also cover 454 up to 461. And that's block 57. Just dividing by 8. If you look at the line numbers, again, blocks get mapped to line. 0, 1. Now 56, to find out what line it is in, we need to divide it by 4, and it goes to 0, and 57 goes to 1. This is the limitation of direct mapped cache. Half this cache, lines 2 and 3, are going to be left unused. But we have a lot of spatial locality going on here by grouping them in blocks of size 8. Okay, let's try this. Let's do the mapping. Pass 1. The CPU in the program counter has the address 0 in it. Well, we know where 0 goes. 0 goes with cells 1, 2, 3, 4, 5, 6, 7. The 8 of those are in block 0. Block 0 gets mapped to line 0. So 0 is a miss, but that's a 1 is a hit. Hit. 3 hits, 4, 5, 6, 7, 8, 9 hits. And then 8 is a miss. 8 goes up to 15 in line 1. We can see over here on the right. Cells 8 to 15. So 8 is a miss, but 9 is a hit in here. So is 8. 2 more hits. 7, 6, 5 are hits over here. 450. Well, 450 is in this other block, so this is getting crossed out and overwritten because this is a direct mapped cache, which is a very thoughtless cache. It should be putting things in line 2 or 3. Instead, it says nope. Cells 448 to 453 go together. Is that the right size? 455. That's better. 448 to 455. Goes in line 0. So when 450 is brought in, it's a miss. It was not there. But it brought in all these other ones. So 452, 4, and 4 are all hits. So let's see how many hits that is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's pretty high hit rate. You'll never get 20 out of 20 hit rate if the cache is initially empty because it only gets loaded on a miss. Alright, let's look at pass 2. 450. Well, whoops. This is how the cache starts in pass 2. It starts with that stuff. So 450 is a hit. It's already there. So we have 1 hit, 2 hit, 3 hit, 4 hits. And then 0 is a miss. And we get this thrashing behavior again, where these guys are going back and forth. 0 to 7 is brought here. That was a miss. And on the miss, it brought in a whole bunch of hits. 1, 2, 3, 4, 5, 6, 7, 8, 9. The next 10 requests are all hits. And then 0 to 7 is overwritten by 448 again to 455 when 449 is brought in. And then we get 3 more hits. And then 2 is requested, which is in the block with 0 to 7. So at the end of that pass, we got 17 more hits. I can just see it's the same length as the bit string above it. And then we are starting with 0 to 7 in the cache and 8 to 15 in the cache for pass 3, which is different than how we started pass 2. So the hits might be different here. Pass 2 started with this in there. So let's try it. 450, right off the bat. It's a miss. So 0 to 7 is thrown out because 448 to 455 are going into line 0. And then we get 1 hit, 2 hit, 3 hits. And then it's overwritten. 0 to 7 is brought back in. So that was a miss, but brought in 0 to 7. And now we have 1, 2, 3 hits, 4, 5, 6 hits, 7, 8, 9, 10 hits. Whereupon it is overwritten again by 448 to 455 with that miss, and then 3 more hits. And then it's overwritten, and 0 to 7 is brought back in for 2. And so we end up with this many hits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we got, the hit rate is 50 out of 60 for the 3 passes. Quite a bit higher than the previous example, which is what I expect, because there's a lot of spatial locality here, and 8 words per line brings in almost everybody. Let's try an example here. What about if it said 512 words per line? What would the hit rate be? Think about it for a second. The hit rate would be 59 out of 60. The cache would be empty at first. The CPU requests word 0. And the cache would bring in 0 to 511. Everybody here is 0 to 511. So this would be a miss, and you would have a hit rate of 59 out of 60. That's what spatial locality does. Right here you can see it at work. You can see this cache example would have been the exact same hit rate and same efficiency if we had a 2-line cache. This is a very simple type of cache, and you can see it's not very efficient sometimes. So in the next example, I'm going to make it a set associative cache. And we'll work out that example as our last example worked together as a class.